the two pain in the butts, I can kick off it quickly and just take care of it right away. So here we go. The rest of you, I don't know you well enough to harass you quite this much yet. Well, Kathy, but that's otherwise.
Feel free. I'm up for harassment.
Yeah, there we go. So on this situation, I'm going to kick right away to the outline just to show you, and we'll jump into it. As I said earlier, I apologize to the people who were here yesterday. A little bit of this will be redundant, but only for the first 5 minutes or so, and then we'll go from there. So on here, on the outline, and I've edited, if you did it earlier, I've changed it slightly from that already, and we've got it. So this session, what we're going to do is go through as much as you want and at the pace you want. For some of you, if you know, well, matter of fact, let me stop that and go back to the screen so I can just see. I can get by hands. How many people have coded in Python to like past lists and through advanced list stuff? Just say, how many people, if you raise your hand, if you've done Python and like do advanced lists? How many people have never done Python at all?
Right here.
Okay. So as you can see, even the people and the rest of the people you've dabbled in Python. It's kind of, it looks like the most, okay. Well, then maybe what I've got in mind seems somewhat appropriate. Those of you who've done advanced list, once again, you can focus on pedagogy and approaches to that. That matters almost more than the brilliance of, we've all had brilliant math professors who knew way more than we will ever know, but couldn't impart that information to anybody unless they were at the genius level already. I always love the statement, it's obvious that, as they're doing notes on the board, and I'm going, I've got straight A's in my master's degree work going on, and I have no idea what you just wrote up on the board. And because teaching was not their skill set, mathematics was. Well, we teach high school. We can't impart information. We have to teach. And by the way, it's a whole lot more fun to teach than it is to impart information. So therefore, that's part of what I'm doing here and focusing on those components as we go down the line a little bit today. So as I now go back to share that one, now that we have that one, the outline stuff here, and everybody's seeing the outline stuff with the new stuff I put on it. Everybody's seeing that screen now. It takes a little while to get there. Somebody can verbalize?
Yes.
Okay, thank you, Michael. Here we go. All right, so on this stuff, as we talked a little bit about yesterday, teaching computer science was interesting. I told you yesterday there was 2 professors I had were involved with in workshops and stuff, one from Willamette and one from OSU. And the biggest thing, Tim was pretty vocal about it. And the workshop, he said high school teachers should not teach computer science. And which was interesting because he was teaching a workshop to high school computer science teachers. So, and I said, well, hold it, Tim, this is crazy. What the heck you talking about? And Mike had talked to me earlier, and Tim was really vocal about it. He says, frequently the kids who take high school computer science come to us and they have radically less success than those of them that start with us clean. And I said, well, hold it. Instead of saying that we shouldn't teach computer science, tell me why, what's going on? And he says, well, they come in and they're very arrogant, in all honesty. Many times the guys are very arrogant, and I am being gender specific. They come in and deal with stuff and they think they know how to code. But unfortunately, what they did was their teacher just gave them problems, didn't teach them programming, may have taught them a couple pieces of syntax, and then just said, you got 2 weeks to solve this problem, which is the worst way to do project-oriented instruction. And he said, so they came to us, they knew nothing about efficiency, they knew nothing about style, they knew nothing about adaptability, and yet they thought they were experts. And so they sucked and frequently failed and dropped out of the entire degree program. So therefore, we need to change that. That's why I said, Tim, no, it has nothing to do with them not taking high school computer science. It has to do with the way we teach high school computer science. That's what we need to focus on. So the problem is like I said, they have an insane amount of confidence, but none of that is backed up by true skill and talent relative to this stuff, which is a shame because those kids frequently have an unbelievable motivation. So we can grab a hold of their motivation and then focus it, it'll work well. And that's why it comes to, there we go, This is a comic that I think is our important. I saw this one yesterday. I love it.
Hey,
The
we saw
Far
that.
Side comic there. Yeah, that's just my favorite because I think that's the point. We have sheep that are very interested. They know what they want to do, but we know where they need to get to. So we're going to just kind of help drive them in the right way. The cool thing, I'm not going to tell them what plant to eat. I'm not going to tell them which direct path to take, but I'm going to kind of direct them towards the right way to go. And that's what our job is. Now, in that same domain, therefore, we provide the leadership and give them the freedom. The other part I talked about yesterday was that the key to success, both in industry, for job interviews, who have, many of you are retired or doing other things, just like me and doing that stuff. If you've done job interviews, I got a job at Google for a couple of years right as I was retiring. And the interview questions pushed me to think in ways that I had never done before. And the coolest part about that, and I think the only reason I got the job is just because I was a teacher. We have 30 bodies a day, 30 bodies a period. When you had double blocks, 200 and some odd bodies a day. And every single moment they're pushing us. And we have to take those leaps constantly to jump out and help them and figure out how to do it. Well, we need to provide that exact same thing in computer science. And I'm going to show you that, especially when we get to lists or arrays in Python, and tell you what most textbooks do and why it sucks really bad. And also that will, those of your kids who are going into take AP tests or IB sort of stuff, that is huge component to success there, because the problems are radically more off the wall than what we usually give our students in the textbook provide. That also leads to the next one, which is a new addition from, if you printed out the algorithm, this outline from yesterday, I thought, oh shoot, for this group, I need to put this. Algorithms are one of the key components. We need to teach algorithmic thought. It's like, I always think of like a master carpenter. My father-in-law was a carpenter, and I loved working with him because he could pull out tools that I didn't even know what they were to do a job. And they did the specific job 100 times as good and 20 times faster. And that's what we need to do, is we need to give our kids the tools. And therefore, if they have these tools, they'll know when to pull it out. And so we need to be teaching them that way, rather than saying, here, solve this problem. We're saying, here's a bunch of tools, now solve this problem most effectively and most efficiently. All right? So before we get into that, are there any questions about the general stuff before we start literally getting into coding and talking about stuff? Questions or comments?
Well, Don, I had a comment about the colors from yesterday.
Oh, yeah, because there's a couple of people there, yeah.
Yeah, I can't, I've been trying here to figure out how to, make a copy of something and put it into the chat, but I can't. So I was just going to say that I've discovered that Python does 5 different kinds of color. And so the 3 that we were doing are based we were doing the RGB, the name yellow, which also Y works for yellow.
Yep.
And then what was the other one? The
Number.
hexadecimal.
Oh, yeah.
So the question really was about the RGB. So RGB defaults to a decimal number below 1. So to change that, you have to the command is turtle.color mode, and you have to insert 255 to say you want to go from 1 to 255. Then you can, what I always do, especially since we're trying to generate random color, is when I do the command for the color, rather than inserting or trying to do a fancy for loop, I just insert the random.randint and then make it 1 to 255 and let it just, every single loop, let it make a new color. So you can, and then you can play with that all you want, but that's the key there, is that color mode procedure to force it to use 1 to 255, and then you can.
Mike, if you want to kick me the code later on independently, then I'll put it on the thing for share. So therefore everybody will get it that way. So we can get that part, might be the easiest way to pull that off for you.
Yeah, I sent it to you this morning in text. So,
yeah, I saw that. Yeah, I was working out, so we did it. All right, cool.
And then you also can do, I mean, if for you guys that play around with printers, you can do that, whatever that printing one is. I can't remember what it's called. It's got 4 values. You can use it, and you can use, there's one other one, but you know, it's very flexible. Oh, I know why. The other one is the one that works with cascading style sheets, or cascading, what are they called? Yeah, style sheets, and XML and HTML, so that you literally have pretty much every way to make a color. You can do it in Python.
Good. All right.
Thanks, Johnny. Go ahead and ask your
Thanks,
question.
Mike.
Yeah, you're welcome.
All right. So on this stuff, one of the ways to organize things, and like I said yesterday, I've worked with several teachers volunteering with their classrooms and stuff from West Albany up to Salem to Silverton and all over the place. And many of them were using some pretty expensive canned packages. And to me, it was insane, the organizational structure, the way they approach things. They would do these really complicated, weird, boring things for kids at the beginning. So all the kids were getting turned off, but I had to use this expensive package. And then they got to other stuff, and I went, the people who are organizing this are not teachers of high school kids or middle school kids, which we got to get them jazzed. So yesterday, those who missed yesterday was with the graphics, and what Mike was alluding to, the colors, which people wanted to push it that way, really adds a motivational component to a lot of kids. And so you can do that. And what I was on Tuesdays, as I said yesterday, that was a session that if you did a computer club after school, or you're doing one of those 6 or 9 week little mini courses that some schools, middle schools especially, offer, that you could do the whole thing based on the graphics component and stuff that I'm teaching on Tuesday.
Don?
Yep.
Hi, sorry to interrupt you. One question I have is a pedagogical question. You can choose to address it or not, but I think it comes up a lot in these classes. It has to do with, once we give them a large program or project to write, and we're going to allow for them to write it any way they like and all that stuff, I would like to know if you have any way of like stopping them from writing the code and actually discussing or presenting their algorithm to each other, to the teacher, because that takes care of a lot of issues for me. It takes care of the dishonesty issue. And then I'm not as uptight in the early stages of my class with, is this really your code or is this mine? I don't care if you share ideas or whatever, as long as your final project is truly your own. It helps to create a classroom community, but I haven't found the most appropriate, the most appropriate tool to get them to share their algorithm with me without touching the keyboard. If you can address that, that would be great.
Okay. I'll tell you what I have done, and there may be other people that have different approaches. I was lucky, I guess that's an oxymoronic way of putting this, but I was lucky to start teaching computer science at Jervis High School on Apple IIe's with double floppy drives. And I had, when I decided to teach my first course, which was never before offered, I had 4 computers and 20 students on Apple IIs with 1 dot matrix printer, which costs more than my entire computer room now, just the dot matrix printer, those of you who are old like me back in the day. And therefore, no one could touch a computer. I mean, keyboard time was insanely vital and valuable. So no one touched it until everything worked. And so then I developed an approach that worked this way. And for me, it's in the developmental stages. That's why I say we start, and it depends. I know people have different, we ended up having a 4-year curriculum at North High. It didn't start day 1 that way. Lord, obviously, that took us 10 years to get to that stage. But the fact came out to be, before you get to projects, you have the other stuff way before that. And therefore, if they understand the discipline and the juice, both, as you lead up to this, then you have radically less problems at the advanced stages. So there's 2 things that I did. Number 1 is that even for, at any level, if you had a question to ask of me, as I told this guy, to everybody yesterday, I don't know about your class, but I had, like in my Java class, I would have 3 levels: Intro to Java, students who've already had a semester of Java and students who've had a year or more of Java in the same period. And so therefore I would have to be teaching different sections. And so my value, connecting with me, was insanely vital then. It was valuable time. So I said, if you're doing your code on your own, you do whatever you want. You approach the problem that I'm giving you and you do it. Now, I graded by hand every single line of code every student ever wrote. You can ask Judson. I hand wrote notes all over codes from intro class to advanced class. And the intro class is actually even more important than the advanced class, because once again, when they start getting a little bit off track, you get them redirected. Then it's less and less stuff. I would probably, in my intro class with a page-long program, have way more stuff written on there than my advanced class with the 10-page document. I would have more written on the intro class. And did that take time? Yeah, bet your tush it did. But once again, being smart and lazy, spending my time early meant I had a lot less issues later. That to me was worth it. Second, so if they had a question from me, then they had to show me the following. You know, and it depends on Judson's group, it depends on the timetable, groups of students did different things. But one of the things I always did was hands-on, which meant you took the problem and solved it as if you didn't have a computer. So if you have a mathematical thing, if we're doing, you're supposed to get a quadratic equation and give me the roots. If that's what the programming assignment was, you had to actually do that in math first. You had to do it just like you do the math problem. And my statement was, if you can't do it yourself, there's no way you're going to tell this stupid computer how to do it. It's really dumb. So you've got to be really precise. And if you leave one step out, it's not going to do the problem right. So I called that hands-on. Now, some students and some problems, if you think about it, they didn't need that. So it's kind of I don't want to demand of anybody something that they don't need. It's internal. They've already got that. There's no point doing that for them. That's cool. If they don't need it and they can write the code without it, perfect. Second, if they have their hands, so they run up to a problem, I would walk by and say, where's your hands on? Here it is. Cool. Then the next thing was, it looks good, I call it pseudocode. And that's the old stuff that we used to do, but I had just broke it down to English. And that is, if you had a brother or sister, or well, nowadays it would be that, but if you had a niece or nephew or friend who called you up on the phone and was asking for help on a problem, your homework assignment, your code, how would you explain to them how to do it on the phone? If your mom or dad wanted to know how to solve this math problem, what would you tell them? And literally write it down. Put it down in that pseudocode. Just write down your solution in English. Because if you can do that, then translating from English to computer science is insanely easy. But you don't miss anything. And then you take your dry run, you take your hands-on code, stuff it into your pseudocode, and see if it produces the right answer by not skipping any steps. Now, by the way, if they do this right when they need it, then when they do an advanced project and they're stuck on one little piece of the puzzle, they can backtrack and do that exact same thing. I don't know if any of you are dumb enough to go to Western like I did for my graduate degree, but I should have gone to PSU because I didn't realize you had to take comps at the end of your stupid, I don't know, do they still make you do that, Judson? You were shaking your head. I don't know if
I didn't have to do that through my program, but I already had my teaching degree, so.
Oh, I did too. It didn't matter what they kept. You know, I love the way TSBC and everybody's. But when I did my master's, even though I had my degree and all this sort of, I had to do comps, which was insanely crazy. And in math, it was really wacko because, you know, you did your fifth year and master's over like 5 to 7 years span, and the professors who taught me my first classes were no longer at the university. So the suckers making, I had the comps, I don't know what anybody else, they had 3 problems from every class you took, and you had to answer 2 of them. So the professors making the problems weren't even the professors who taught me the class. So their problems had nothing to do with the stuff I learned at times. So what was cool is this hands-on pseudocode approach that I forced onto my poor students saved my grade and my pass and my comps multiple times when I was taking that test, because it works. It was a process that was effective. And I was able to bring that back and say, yes, guys, this helped me save my grade and my degree because exactly what I'm doing there. So I don't know if that helps you, but that is one approach we do, that you make them do that process. Two is, and I don't know, Judson, we did this later on for the advanced projects class. The senior year at North, when we built up to a real project, and I'm not sure exactly because there's different levels of code, but students would do an entire project for a semester or a year, depending. They had to do three things, and this may resolve the cheating and all the other stuff. They had to create a tutorial. Matter of fact, I'll be honest, how I learned Python was from one of my former students. The young woman, her project way back when was, I want to learn Python, Kirkwood. This is a new language that's coming out. I heard it's cool. I said, there's your senior project. You got it. So she learned Python. She had to create a tutorial, a document. Hers was about a 35-page document explaining how to do Python. Then she had to get up in front of the entire class and teach an hour-and-a-half lesson on Python to the whole class. Now, how I learned Python? I ain't no dummy. I took her tutorial, graded her tutorial and her codes, and that's how I learned Python in the very beginning. So my student taught me how to do it. Now, you can't cheat on that spectrum, that scale. And so therefore, even a presentation on a small project, when you have that, sharing that, making them come up and share and explain their code and stuff, I think resolves a lot of those issues. So that was probably a lot of stuff that was beyond what you were asking there. But I hope
that's
that
great.
helps.
Thank you, Don.
Yeah. I'll be honest with you, when the students get the jazz, and that's the problem with the system, the way we do when we do it shorter term, by the time they got to be seniors, and Judson, you may disagree with me, which is cool, but I looked at it and the fun, the intellectual juice of doing the stuff stopped copying. And I can't remember, I had a bunch of people cheat on my English essays and in my English classes that I taught. I had a bunch of that I would find. In computer science, they would do quirky things. Matter of fact, that was the other twist. You could change their project just enough to make it do something personal that cheating wasn't, they didn't want to because it was fun doing this. This is what the juice was. Cheating in the math class or an English class or history class, that may have been completely different. But this was for them, not for me. So I don't know. Other responses or other ideas from people?
I'm just going to add a few things in there in the chat, Kirkwood. We've got people who are sharing ideas, and Judson was helpful in creating a document in that Google Drive folder that you set up. So please, if you have resources you want to share, ideas, just add them to Judson's document in that file so we can keep on moving and so that we can all share with each other. So thanks, Judson, for doing that for us.
Great, yeah, that's a type. And when we were in rubrics and all that garbage, I designed multiple rubrics because I was on the, oddly enough, the committee to make the math rubric when we did sim and cam and that crap. And then on the English, I don't know, stupid things to do, but I was on that committee making that rubric for essays and writing and stuff. So therefore we made AP, we made rubrics for the AP committee when I was on that for CS. And we had that. So sometimes rubrics help. Whatever makes you work with your students, there's resources all over the place. And being old, you go through the cycle. Oh, we did that 10 years ago, but no, someone's getting paid at the district to do something new. So we want to interject this new thing. And you go, that's exactly what we did back in 1973, but that's okay. All right, not quite that far back. That was when I was in high school. All right, cool. So syntactically then, we'll dive into that. Please stop me and let me know what's going on. I'll share just a little bit the sheet that I gave you called Intermediate Help Sheet. It's just like a brief summary of stuff. And we'll just talk about that. And I will share that here real quick, like the screen there. I've got it up here, but if you see that, it's got some general stuff. We're not going to deal with the graphic stuff, as I alluded to. That's the Tuesday class, but there's a template for the basic turtle graphic stuff. But below that, there are stuff relative to math, the functions, the mod and exponentiation and plus equals and stuff. Those of you who did Java or C++ know some of those. So you'll see some of the operators and stuff. We're going to get into the syntax for the conditionals and looping. Right below that, the basic syntax for all constructs is the command line, the command pieces, if, and or, while, for, and so forth, but all the constructs end with a colon, and the content that is internal in the construct is indented, and we'll show you some code, we'll do it, and you'll see that it automatically does that for you. Once you do the colon and hit enter, the compiler, the IDE, will indent for you. Once again, we'll talk about this. Using break or continue is just, I'll just be real explicit. It's crap code. It has no point hardly ever. And if you break the rule, in my class, you automatically lost points. And I made you come up and justify it to me. And if I couldn't write the code more efficiently without it, then you got the points. And that occurred once in my entire career. So there's no need for it. And unfortunately, a lot of books and online courses show that it doesn't do effective. So there's the basics. And I think I'm going to jump right into coding and seeing stuff if that's appropriate for you, unless someone wants to do otherwise. So if you want to, you can load up code 0 for compound interest. And I think you guys are all looking at this now. I switched screens.
Yes, we got the code done. Looks good.
Yep. So in this code, and someone asked yesterday, and yes, I have put this up front so we have this all the way. But if you're creating your own code cold, you just get into whatever your IDE is and go File, New File, and it will just pop you a screen like this that you're now ready to type whatever you want to type on it. And the cool thing with Python's IDE with idle, it automatically, if you do any editing, it'll force you to save the document before you actually even execute the code. So it's kind of nice that way. As we alluded to in the notes, when we looked at the outline, once you finish linear constructs, and if I was doing this in class, there's several kind of unique problems to the kids think they know stuff, but I've seen some really bad ones. The thing that was helping from West Albany had to make a bunch of pictures, and since it was a code that graded their program, so you as a teacher didn't grade their code, the code did it. The CAN software did it. They would have them say, make this picture. And it was made with parentheses and apostrophes and all punctuation mark. And if they made one extra space in their code, it would come back saying it was incorrect. And I just went, because I did it. I was running this thing to help her students out and give advice and stuff. And I looked at this, and it was the most frustrating thing I've ever seen in my life, because here I'm doing this, and I'm thinking I got it perfect, and it says, no, it's wrong. So finally, it was garbage. I would literally copy and paste it from the question and paste it right into my code, and it would still say I was wrong because someplace I had an extra space inside of a quote. So those I thought were insanely frustrating and poor linear codes. There's some fun ones. You can do like, for linear, one of the good ones is have the students input an integer for an amount of change, like 95 for 95 cents. And then have them print out the total number of coins it takes to make 95 cents. Now, some of you who know what we're doing here, and this is redundant, there's a little code for you to do while I'm talking about other things. Without any looping structures, without anything, either use a constant for the amount of change to start with, but output how many coins it takes with no looping, no decisions, nothing. Just linear code. See if you can pull that off. That's kind of a fun one to mess with while I'm introducing some of this other stuff to other people. So if we look at code 0, as I said, one of the things we want to teach is algorithms. And also the cool thing along the side is if we introduce stuff like mathematics and business and arts and science into our examples, they're learning a whole lot of junk on the side. I love this one just because kids think, let's buy a car, and they don't handle credit cards very well when they're at college. Kids, when I'm talking about kids, 35-year-old kids. But anyway, they don't know the cost factors relative. So a simple program like this, which is compound interest. And the problem set would be input an amount of your car purchase, how many years it's going to take you to pay off, and how much interest you owe, how much they charge for it. And this code, what we have is on the inside the for loop. So looking at the syntax, I don't know. And since I've got the screen shared, I'm not seeing your faces. So you'll need to verbalize. Is there any bit of the syntax in this program right now that anybody has a question about before we talk about the algorithms and the other piece? Or is everybody beyond that scale? Everybody good? Someone keep track of this. Mike, you look at the pictures and everybody's got their thumbs up. You say everybody's good. Here we go. All right. Charlie, your mic is really buzzing out again. I'm not sure exactly why, but yeah, it's got the same issue that we had earlier.
All right.
Is it plugged in all the way?
Yeah, unfortunately, yeah. Well, Mike's trying, and anybody else can interrupt, and then he can come back in. I have no problem with multiple people doing stuff. So, does everybody understand the syntax? The for loop. In Python, the for loop is for, and then you choose the variable in range, and then you have a set of parentheses, and in there it actually has 3 pieces. More elaborate one. You can do beginning value, ending value, and incrementation separated by commas, but then you have a colon. And after you hit colon, if I'm typing along here, as soon as I add the colon, if I hit enter, the IDEs almost always automatically indent, and everything, unlike Java or C++, Python indentation is known for embeddedness. So both the interest and the price line are now embedded inside the for loop. If one of them wasn't, it would not be inside the for loop. So Charlie, sorry about that. I don't know. Maybe if you want to write a message and then someone else write it to Mike, and then Mike can verbalize it to me, since he's done this, I know, multiple times. That might be an effective way to pull it off.
Don, I have a question.
Yeah, great. What you got? Yeah.
So that let's see, line 1, 2.
Yeah, I wish.
It'd be nice if they were labeled, wouldn't it?
Now, well, I had them that way, but that's one thing I don't like about Google Docs is in Word, I had the line numbers on the code and everybody could go, but here they don't get line numbers. So sorry, just tell me the first word. Yeah.
So I'm looking at price equals interest plus price.
Yep.
It's the last under the loop, the second from, yeah, there. There's no confusion with price being listed twice in there?
Matter of fact, it's got to be, and that's perfect. Great question. When we talk about algorithms, that's one of the algorithms. If you looked at my list there, summation, a summation, and that's why we practice this. Actually, in all honesty, the cool thing, the linear program I told you about doing the coin chains, that is one of the places you teach that algorithm. And the idea is in any programming language, when you want to add stuff up. So therefore we say, okay, let's total the numbers between 1 and 5. So our tote, and you could go tote equals 1 plus 2 plus 3 plus 4 plus 5. But then I say, cool, now make that from 1 to 100. And you go, no, we don't write that code, right? We want to do a nice little for loop that does my numbers from 1 to 100, and I want to total them up. I want to sum them. So the line of code, we do the hands-on and pseudocode, exactly right. That's what we set it up. So what you do, you go tote, starts at 0. We need to do that because it depends on the language and the IDE. Sometimes the computer C just grabbed the value out. So whatever you put in memory, it could be 3,012, or it could be negative 901. That's where it would be initialized to. So therefore, you don't want to take that chance to do that. So you say, my total starts out at 0. Then what do I want to do? Every time you got a new number, I want to put it to total. So hands-on, you go tote, and we go tote plus 0. And then I change 1, and I go, aha, it's not 0, I'm adding 1 to that, it becomes 1. And then 2, so it's 1 plus 2 is cross off 3. So how do I get that? Tote equals tote plus num. So that's summation, and you're thinking, which is right, it's cool, but it's insane. When you correct AP exams, this is supposed to be the advanced placement, you will get kids doing unbelievably stupid things, hard things, to do a simple summation process like this one. And that's because they were not taught algorithmically. They were just saying, here, solve these problems, and I don't know how they solved them and why they're taking an AP test, but the fact came out to be they never learned that anytime I want to add stuff up, I have that exact line of code. Variable equals variable plus something. Exactly right.
I have a question on the data types.
Yeah.
Rate is a float, but price is not. It's an integer. And when you take rate and divide it by 100, it still makes it a float anyway because it's division. But when you add it to price and then stored in interest, which is an integer, does it turn that into a float? Is it truncating, or what's it doing?
Yeah, when you go price, see, it's interesting, the different Pythons, when I first learned Python back in Python 2, when they created Python way back when and stuff, they used to say, we don't need to type anything. If it's a duck, if it looks like a duck and quacks like a duck and swims like a duck, it's a duck. And so there was no typing anywhere. But as Python become more of a professional application, which it is now huge professional, that doesn't work because it takes too much time for the compiler to figure all this, or interpreter to figure all this garbage out. So now we type things more. And in reality, what you're talking about, you're right. Here, if you look at the first 3 lines of code, when you input something in Python, and I was going to talk about this later, but this is a great time to do it. When you do an input in Python, it automatically inputs it as a string. Therefore, I have to typecast it as a numeric value if I want to do mathematics with it. That's why that price equals int, parentheses, input, parentheses, type in the price of a car, parentheses, parentheses, is the code that we need to pull that off with. So we input is a string. Now, by the way, you could do 2 lines of code. You could say price word equals input blah, and then price equals int of price word, or something of that nature, depending on your, but this is what we need to do with Python syntax. Now,
I just have a quick question too, is that's not how I used to calculate compound interest. So I'm trying to figure out how to get that into what I'm used to.
Some of you may have done like the big mathematical formula straight up, but this is like simple. If you have, I taught my first course to freshmen always. And so therefore, most of the people were allowed to be here if they did Algebra 1 successfully. I'm simplifying this, but yeah, and there's, by the way, a lot of different ways. And if a kid came up with a different way, that would be 100% okay with me.
Oh, okay, because I mean, I'm used to like the exponent and all of that other stuff.
Yeah, well, that's, the mathematical formula, and you wouldn't need a for loop at all. You just plug it into the formula and you got it.
Okay.
But how many of us, in all honesty, and I know I would be saying no, how many of us have memorized that formula and could use it on a daily basis? This is what I do. Pardon?
Math is not my, I admit, math is not my favorite subject.
Yeah. Well, and this is what's cool about this. This shows the kids, in all honesty, when I taught Algebra 2 or pre-calculus, and we were dealing with some of those formulas, this is where I would start. My computer science really helped me. I said, this is what we do. Now, how can we actually convert that and end up making that mathematical formula? So it actually, this is a real cool way to do advanced mathematics too.
All right, John, one more question. Sorry. I think I interrupted someone else.
I'm not quite done with my question. What I get was if you multiply that float by an integer, you're saying it truncates it?
Yes, it does. It'll truncate it, and therefore price will come out to be an integer. Yeah, so we got all the other stuff. And so one thing I talk to my students, I say, hold it. If we look at this, what is this the actual answer? Because if we run it, we'll execute it right now. I typed something, so if we run it and we type in the price of a car, $100 and 5-year loan, 18% interest, notice what occurs.
But you're getting a float out of that.
Yep. All right, because Python will do that at this stage. And notice one of the problems coming out to be is that it has all the decimal notations all over the place relative to that. So in this case, if we change this, you're right, we got a float. If we change this all to floats, it would come out with the exact same sort of structure we got it. If you did the mathematics with it. In this situation, I was just playing with stuff and showing the kids, and I'll probably be that, because I really didn't want to have that question at the time. If I change this back to int, right? Because now look, now when I do an int divided by int, what's going to occur? And now you're going to understand why I did that as float when it happened. What's going to occur now, folks? Everybody think on your own. All I changed is one typecast. My rate is now an integer. And now think, don't verbalize, but think, and I'm going to run the code. I'll do the exact same thing. 100 for 5 years at 18% interest. And we came out with it. Now, would this work this way in other languages?
Wouldn't work that way in Java.
Not in Java, nor C, nor C++. So Python is weakly typed, right? If you want in C++ or Java, if you did that, if you did rate /100 and rate was an int, it would truncate puppies down the line.
Now,
In Python, it lets it go. It says, no, you really want. Now, by the way, you can int that, and then we would have major problems because it would be 0 every time, and so forth. You guys are getting into deeper questions than I wanted to do, but that's actually perfect.
now I do have one thing here is when you type in your integer, you can't use commas or anything else like we teach the kids to do in math.
Correct.
Okay.
Even if it's a float, even if it's a float is a real number in Python and C++ and stuff.
Okay.
And C. So even though it is that, yes, you can't use any symbol other than numbers.
So if we were doing, Elon Musk's car at $1 billion, we've got a lot of zeros that.
Correct.
Okay.
Don,
Yep.
Sorry, is there a way to round that answer to 2 decimal places?
The cool thing, well, for the output, it is really tweaky. Python is not made to handle that stuff very well. Now, unfortunately, many textbooks and many tutorials start playing those games. It's like those of you who learn C or Java, and all of a sudden they're pulling out the entire Java graphics package, which is insanely convoluted, and saying, let's just use this, and don't worry about the details, just use this command. And you go, no, no, no. So yeah, if we look at help, this is maybe a good time to pull that off. If you looked up help and went to Python docs help, which it'll pop on, I'm just waiting to see, yeah, it did pop out on that screen. You can look through anything here, and if you type in the print command, there are see, there's a built-in function, and there's a whole bunch of stuff here. And I think this one, I haven't done it in a long time here. It will start taking you to commands and talking about all this stuff with flush and with standard outputs and strings, and you can concatenate and you can do, there's tons of stuff with it. But the fact comes out to be is the very beginning, in all honesty, I tell the students, let's just, right now I'm not going to worry about style and stuff. We're just looking at the pieces of the puzzle. Later on, especially when we get to strings, we'll play with that more. At this stage in time, it is not worth the syntactical energy and boredom on their part, in all honesty, to worry about it, in my frame of reference. Okay, everybody or not? Now, by the way, one way to avoid all that ints and all that other junk in the first place, if I was teaching this to kids right off the bat at this stage of time, I would not be having any of this at all. I don't start this way. I start with it all just being constants. Well, actually, let me do it this way. I always just start it with this way. Whoops. I just put them in so that they just use constant values right off the top so that they don't mess with a lot of those details that get them confused right at the beginning. So I just say run it this way. Because in reality, that avoids a whole lot of the questions that you're alluding to, and it would make it cleaner. For you guys, I did the IO just because different values that were coming up here. Personally, I would hold off on that with my students until quite a bit later. Okay.
Was the rate of float because you often have interest rates that are not whole numbers?
Yeah. Okay. And if you didn't do this 100, depends on how they pull it off, right? You may not have divided by 100 and the student may have entered 0.18, right? It depends on how you verbalize the problem in the first place, how you want to set that up, how you gave the problem set to them. And it depends on where you're talking about relative to their math background and relative to the way you want to focus it. It just depends on what you want to do there. Yes. Now, you guys, maybe this was a mistake. I'm diving into this because I want us to get as quickly as possible we get here. And in reality, if I was doing what I'm doing with you guys, is not what I would do in a classroom setting. I start doing that if you want me to, but generally speaking, I'm just going a whole lot faster pace. We would have done 3 or 4 linear codes, one of them being that code change, coin change one. I would have done several with mods and divs and checking some things out relative to that. I would have done several programs relative to that first with my students before I would have even jumped into the first looping construct. Those of you who did stuff yesterday, that means I would have done some of the graphical stuff and done a line and drawn it. But before they jumped into the for loop, we would have taken a little side juncture and taught them a couple little math things with percentage and stuff like that, and then jump back to the for loop if I was teaching an entire course. Okay.
Hey, Don, I had a quick question for you that's off topic of this current program. With the recent announcement, at least from Salem, Kaiser, and Portland schools, of going fully comprehensive online education, most schools are implementing their programs using Chromebooks. So the question that I have, you're currently using an IDE that is not an online IDE. I know of Replit, but other than that, I don't know if you are aware of any other online IDEs that might be useful.
Yeah, actually, I don't think I can't remember if I shared this with the intermediate group or not, but yeah, and it will. If you look at the intro group, everybody got both pieces of information. So if you look at your intro group, under documents, there's one called Python 363 install. And on the bottom of that, and Mike Reams found this one, Pydroid 3, works even on a cell phone. And so therefore they can do that. And Trinket, the one when I worked around West Albany High School doing those, they use Trinket to do their Chromebook one. And there's a link to Trinket's application on that install sheet that I gave. It was called Python Setups, and that was in the intro class one. So those are two that I know will work with Chromebook. And if you have real deep ones, Mike Reams does Linux and all that garbage and knows a whole lot of different ones and how to set it up in ways that might be very effective depending. Yesterday we did Raspberry Pi, setting it up on one of those. So Mike is a great person for that piece of the puzzle.
I was just going to suggest looking up Raspberry, because Judson, are you doing robotics too at your school?
A little bit, yeah.
So Raspberry is what it's sort of the machinery that lead to robotics and electronics. And so if your kids are already used to the like the IDE, then you just use the same thing. So check out Raspberry.
Hey, can I just ask Nick to please mute? I think there's a lot of noise coming from his.
Yeah, and I don't see pictures. I know it's coming from somebody, but I'm not. Yeah, thank you. Yeah, I can't see who it is where my screen is.
It's one of the people who doesn't have video, but it's really, I don't know, there's something going on there.
Okay,
I wanted to
I got
mention, as far as the online IDE Replit, it does allow turtle graphics, which is one that not all online IDEs allow. So just wanted to throw that out to people. I put that on the resource page too.
Yeah, thanks. Pyroid 3 does that also, and Trinket does that also, because I was using those things down in West Albany, as I said, and Trinket seemed to be a real easy one also. I don't know the one you're talking about, Judson, but the good thing is to get linked up with someone like Judson who knows an IDE, is it's a pain in the neck to play around with the stupid stuff. You want to get into the coding, so talk to somebody who's already jumped through all those hoops, get the links and whatever it is to make that stuff. So Mike and Judson, I think, would be great resources for that. Okay. All right, now let's move on to the little other codes and we'll start seeing, I think, what's going on. And once again, for a more complex summation line, factorial is an interesting one. So Mike and I like number theory. It's just kind of fun to play with, but a lot of people aren't going through. So I like to try to pull examples from business and for number theory. And I like problems that I know that if kids do computer science, which is what the engineering and CS, that's what my goal was for a lot of my students in my classroom, I know what they have to go to. So if I could teach them things like Fibonacci and factorials and stuff like that, when they get to discrete mathematics and they get to their application, they are way ahead of everybody else in the classroom because they've done it ever since they were a freshman. Plus, it's really kind of cool when you walk into the math class and all of a sudden you're the top of the class rather than the bottom of the class, just because you've had experience with these things in a fun way and you know how they actually work. So if you look at the code 1, factorial, why is this a summation line of code? Factorial is 6 factorial, or 6 exclamation point, is 6 times 5 times 4 times 3 times 2 times 1. Okay, that's factorial. That's what it's defined as. And if you do that hands-on and check that out and see what's going on, you'll begin to understand why this is a summation line. Because what are you doing? Summation doesn't mean just addition. You're using that line of code, answer equals answer times factorial. Now, once again, I would not jump into this cold like this with students. I'm showing you for this class, I'm doing like, and you could say, Kirkwood, no, this is not effective. We need to do it a little bit more stepwise refinement. And I'll go, cool, we'll back up, we'll talk, we'll create some codes online here as we do it. If this was my classroom setting, I'll be honest, what I did when I gave assignments, frequently I gave 3 codes. They worked the exact same amount of points. Sometimes it was 2, depending on the group and how much time I had. But I always called it a C, B, and A program. The C is almost like, if you think about, maybe we could do it reverse. If you look back at your math classrooms, the first problems you had in your math assignments were exactly like the examples in the book. Exactly. The words were slightly different to the numbers. That's it. So therefore, I always call them my C code. That is, if you can do this, and you take my test, if this is your level, you're going to get a C on the exam. If you chose, but I said, if you got a busy day, things are crazy on your homework load everywhere else, well then do the C one. You got the basic knowledge, go past it. As an allusion, if people are interested at the 3rd week of this and you're still coming and doing stuff, I have an entire year's outline with homework problems, answers, worksheets, tests, quizzes, codes, everything that I did when I was in Korea. And if people are interested, I will just give that or share that to anybody and everybody who wants it for you to twist it and turn it and do anything you want. But there's no point in me giving all that out at this stage because it would be useless to most people. So keep that in mind later on. If you're interested, I will share and I'll refine it and get it polished up and share it with anybody. But the C problem was the easiest one. This one would probably be an A problem for a for loop at the beginning stuff. Because if you think about it, it's real short and sweet, but the thinking behind it is two parts complicated. Number one, the summation line is a little weird. And two, the for loop is a little weird. And please look at that for loop and tell me why the constraints on the for loop are the way they are. Somebody.
Is it because it counts up to num plus 1, but not num plus 1? Is that what you're trying to get at?
Well,
Correct.
we're computer scientists
So,
here,
yeah.
right?
What's that?
We're computer scientists. If we're considering this, computer scientists always start at 0.
Yeah. As a matter of fact, it's a great lesson to start with kids early on because when we get to lists, arrays, C++, Java, and Python starts their addressing at 0. So to get the kids' brains going, yes, the for loop, the ranges automatically start at 0. And so if we had a normal one, when, like I said before, if you want to do something 5 times, you could just say in the range of 5. But you got to understand the computer is going from 0, 1, 2, 3, 4, and it kicks out when it gets to, because it's less than that value. So exactly right. And by the way, if I was teaching this to my students, we would have done several for loops with that demonstrated multiple times, leading up to them making a dumb mistake and going, how come mine's always outputting 0? And that's what I want them to learn. But with you guys, we jumped ahead several codes to set this up. So if we do a factorial, 6 factorial, we want, and it doesn't matter if we go 6, 5, 4, 3, 2, 1, or 1, 2, 3, 4, 5, 6, multiplication is commutative, it doesn't matter. So therefore, this goes 1 up to, if I wanted to go to 6, I have to put a 7 in that loop because I need the 6 to be in the multiplier. All right. So a more elaborate, challenging summation line. And I don't require the kids personally to do jargon and they call it that, but I'm going to use it all the time. And then soon, guess what? They start innately doing it. And that's our goal. Any questions? Are we ready to move to the other one? Or since I don't see your faces and well, I'll just flip back here. Where are we? Are we ready to zip to? I hate this part of it, guys. Don't be honest with you. Teaching you guys face to face, I could know right now, I could tell where everybody was. I would know I need to do 3 more examples leading up to this, or I would know that, no, we should be skipping to the 10th example ahead. Kirkwood, you airhead, you're going way too slow. And now I can't even see your faces because I'm looking at the stupid screen. So I apologize for my inability to teach you guys. Maybe I'm going to not. Do you guys have the code so I don't need to share it? Or is it good to show it on the screen?
It helps to share it on the screen.
It really
Okay.
does.
Yeah, it's a trade-off. I can look at it right here, but if I share it on the screen, I don't get to see it. So that's the way it goes.
Get it.
Okay. So do I need to backtrack and do some simpler for loop codes? I was trying to do summation. That was our first algorithm. So I was trying to show a fairly simple one, compound interest, and a pretty elaborate one, factorial, and show you those two and do a for loop with some constraints on it, different constraints. We got it? Are we ready to move to the next one, or where are we?
I'm good if we move on.
If you want to move on, give me a thumbs up, give me something. The eyeballs, I can kind of tell, I think we are good. But I pity you guys. I'll be honest with you. I pity you. To do this with 30 high school students, you have all my prayers, all my best wishes. And matter of fact, with 1 or 2 of you, I may help you even more beyond that. We'll see who sticks out this whole term and does stuff. I may be talking to a couple of you about some opportunities. We'll see. So here's what we got. All right, so if we've got that, now we're going to share the screen for the next section of code. And that one is we now move into the system construct. And this is a fairly elaborate decision construct. So if you guys want a simpler one, we can do that. But I jumped up to factorial with imaginary roots right off the bat. So this is code number 3. I should have done other things. So if you know quadratic formula, right, there are 3 possibilities. Either it's an imaginary number, i.e. the square root of a negative value, or it has 2 answers, or there's only 1 answer because they're both the same. There's only 1 root. And the only reason I did this in this way is to demonstrate the construct, the if-then construct, and how it comes together in Python. So if you don't know the math and don't understand it and don't give a rip, fantastic. You can just look at the construct. The way the code works in Python, and I'll get rid of the additional spaces that happened while I was doing something else probably. First of all, in order to do some of the mathematics, you need to import math. If you look at the commands, there are functions built into Python that have phenomenal tools. And math has a whole library of phenomenal mathematical tools that are not needed on a general basis, so there's no point wasting memory on the computer when you're running these things. So therefore, there's libraries of these, and one of them is math. For my advanced students, those of you doing advanced Python, or you have a student that's really quick and they're good at mathematics and you want them to do some extra stuff, making their own library is a phenomenal tool to do. That's a cool project because then they can make their own library and use it with their own math functions. Or if they're into art, they can do some functions relative to that. And then they can share it with their fellow students, or they can blow away their math teacher because they have now done all their specialized trig functions or whatever it may be with their own names. I had a student, an advanced project student, his project was to take, if you've ever done C++, their graphics package is just putrid. It's just insanely complex. So he did a wrapper class that took all the C++ graphics tools and made them just like Turtle graphics. So you said, move forward, just forward. And it would do all the commands embedded inside. And the response he got from his fellow students was unbelievable. So, and you can do this with a first-year student who's just real quick in your Python class. Instead of him or her being a pain in the butt, just have her go out, teach them real quick, or don't even teach them, say, learn how to make a library, like import math. And then make your own with these functions from I know you have Mrs. So-and-so for your teacher for science, for physics, or make up all the science functions that you do and make your own library for that. And then come back to share the class. In all honesty, the stuff they're going to be doing is linear constructs or looping constructs, that's all. But they will be able to share it at a real high level, which is cool for them. All right, so looking at this, are there questions relative to this?
Yeah, I think I remember some. It looks like you're using 2.0 there.
Yep.
And that has something to do with division and types, doesn't? Is that true? Or
Correct. Correct.
I don't remember all.
And yeah, and it depends. And sometimes, by the way, I'll be honest with you, there are different levels of Python. There are different languages. So let me backtrack. I tell my students that I don't want to teach them Python. I'm teaching them how to program. We just happen to be using Python. So when they leave Python, they're going to move to, if they were in the sequence at North, they would do Python for their intro course, and they're going to move on to C++ and Java for the next 3 years if they're a freshman. And I don't want them to learn habits in Python that they're going to have to break when they move to C++ or Java. That's crazy. It's so hard to relearn. It's so much better to learn the right way in the first place. And so with types in C++ and Java, as it's already been alluded to, when you do the division, the slash, if A happens to be an integer and you do 2 divided by A, and A is bigger than 2, it's going to produce 0 every time. And all the errors are insanely putrid. And if you do 2 divided by 2, it's going to produce 1, but 2 divided, it's going to really make weird results. So I say right now, yes, Python, can you get away with just putting 2 there? Yeah, in most Pythons, just as we saw with the compound interest one, it's going to work out just right. No problem. But do you want to learn to think that way? And the answer to that is, I don't want you to. Will I grade you down on it? No. But in all honesty, myself, I make a little teeny comment. Say, this is cool, but you're good enough. I know you're going on to next semester. And this will screw you up. So you may just want to get used to doing 2.0. So great. Very valid question, but thank you. Now,
I have another question. Sorry.
No, Kim, no, sorry. I can't look at you until a question's coming, so
Okay.
please interrupt.
You're right. Okay, so the if else statement, you've got parentheses around the condition, which is not required in Python, I don't think. Is it
No,
required in idle?
no.
But do you do it for habit, just like you were talking about?
Correct. And also, if
Okay.
you add a conjunctive disjunctive statement, ands or ors,
Okay.
if we expand, once again, see, I don't want to relearn squat. I'm too old. I don't have any brain cells left. So therefore, this is what I tell my students exactly. And Judson, those guys thought I was old way back when I was teaching them, and I also said it. But the fact comes out to be is, if you have to use these at some point in time, to me, it's easier just to get the habitual process to do it. And by the way, in other languages, you have to have the parentheses there. So therefore,
May I ask something?
Pardon?
May I ask something?
Yeah, sure.
I think
of course.
in the requirements of the program here, I think that A must be different of 0.
Correct. Oh, yes. Oh, yes.
And I don't see something like that there.
Oh,
because
well,
if it's equals 0, then we don't have a quadratic.
Correct. And matter of fact, once again, you have 2 options. It depends on your students in your classroom setting. I either will just verbally say that, or you can actually even test it. You're right, but most non-mathematical students, most freshmen that we're talking about, won't worry about that. But you're right. In all honesty, in the problem set, I would probably give that in the actual problem set so that they didn't have to delineate between that. If I was teaching somebody that everybody in my class was a pre-calc, I would really want to, I would be trying to nail them with that. But if I'm teaching kids who are in Algebra 1 or just completed Algebra 1, I don't worry about it. So you're right. In all honesty, I should have, if I'm doing this precisely mathematical, I should have another if in the very beginning to trap that one and say, this is not a quadratic. Exactly correct.
Thank you.
Yeah, of course. And matter of fact, once again, that's your precision. It's interesting because it's like I had 2 different conversations here. A second ago, I was saying, I don't want to relearn anything relative to syntax and coding. If I know it's going to be in C++, I started implementing that when I'm doing Python, even if it's not required. But mathematically, that ends up coming out to be something slightly different in my frame of reference, just because the kids get bound up with that. By the way, this obviously, I hope you noticed, this is obviously an A problem. This would not be a problem I give them to them the first time I gave them an if then else sequence, right? We were doing a whole lot of other stuff, and this would be an advanced A-level code right here.
Hey, I've got a question about something that you mentioned, not totally related to this problem, but just the best programming language to start with.
Okay.
I've taught some JavaScript to middle schoolers, and I thought maybe Python was a step up for high schoolers, but now you're saying that in your program, they went from Python to JavaScript. What's
Not
the
to
best
JavaScript.
language?
Not JavaScript.
Oh, not
just
JavaScript.
Java. No, never. I never taught JavaScript at all.
Okay. So
yeah.
what's the best place to start? And what should high schoolers be which language would be best for them to learn?
Well, I think there's multiple factors there. Number one is in all honesty, in this entire question, I'm going to go back here because I want to look at you guys. So in this entire question, you are the most important piece. I cannot stress that highly enough. I don't give a rip if you teach BASIC or Pascal. By the way, Pascal is actually a good language. I don't give a rip what you teach. I do care about your relationship with your students. You reading your students and giving them what they need and what will work with them. That's what matters more than anything else. Now, in that relationship, to me, personally, see, Mike and I were talking lunch yesterday after we did this session, we got together for lunch. We were talking about how CS people, my gosh, I taught for 38 years with overseas stuff. And I learned brand new, Python is a brand new language to me 6 years ago. I never taught Python once at North High. I retired from North, moved to Korea to do it. I said, this is crazy. Python really would be the best thing I wanted. So I really got into it and taught Python straight up. Why? I choose Python for two reasons. Well, multiple reasons. First, the graphics are insanely easy and cool. Kids at 5th grade, like I said, I taught it at a 5th grade computer club, and they were so jazzed about it, it was unbelievable. And I could take them to mathematics and geometry stuff that was slick for 5th graders. They learned, we ended up proving several things using that TurtleGrafx stuff that I'm doing on Tuesday. We took them to places that I know their geometry teacher 2 years from when they, or 3 years from when they are going to be blown away with. It was cool, and they came up with it. Two, Python is a professional language. You are going to run into parents and administrators, and if you want to, at the end of this conversation or some other time, I've created a PowerPoint, and I've shared it with you guys, that really says, why should we be teaching computer science at all? Administrators are, in all honesty, they have so much pressure on them with tests and other crap in music, district administrators in music who apply a whole bunch of pressure on them. They are completely ignorant about what we do in almost every place. And they don't understand why it matters. And they're just like, let's say like in some virus discussion, there are a lot of people who are completely ignorant that other people listen to. Therefore, we have to provide a message that has validity in all ways, shapes, and forms. And one of my messages was, for CTE, is that jobs matter. I want my kids at North High, a real low socioeconomic place. When they graduate from high school, I want them to have a skill that they can earn more money than I can the moment they graduate from high school. And it happened for my students who started at Freshman North. And one of the reasons is Python, the argument for Python, commercially it is huge now. It is one of the biggest commercial production language. It and C#, and then there's C++ and Java, they're in there. But Python is the fastest growing one. And I know at least I have like 40 former students working out in the field, and I constantly am saying, now what should I be doing? What should I be telling people? And they say, people we're hiring, this is what we need from them.
Can I
jump? That's why it's a great intro, phenomenally easy intro, but yet it can go all the way up to AP. If you taught the first AP course, not the AP Java class, but the other one, I always forget the stupid name, sorry, but it didn't exist when I was involved with AP. If you could do Python to teach that class, so you could teach a semester intro to Python and then move right into AP using that Python. So it's easy to start with, phenomenal graphics, and could go up to an insane high level. That's why, now JavaScript, I've heard somewhat similar arguments on I'll be honest with you, my perspective, a weaker level than that. Also, the other thing is Python, the third piece, the transition from Python to C++ and Java is insanely easy. I always wanted to do the following, and it happened at North. And we used to teach Pascal as our intro language. Pascal had dynamic data structures and pointers and all the constructs and functions and procedures. So everything I taught in a year of Pascal, when they moved to C++, which is what we used to do in the beginning, when they moved to that, I want to teach them everything I taught them in the year of Pascal in less than a semester of the new language. Now, how can I do that? Number one, they're faster. Number two, everything I taught them here transfers to the new language. So what I took 3 weeks to teach them in constructs in Pascal, I can teach them in 1 week in C++, because it's all the same. And then when I do Python or Java next, I can teach them in 2 days. So by the time they got to their junior year, the AP, we did AB level, and it was all review. I always loved the students coming back and saying, yeah, I did all the coding and I had a half-hour nap. Now think about any AP class you ever taken. If you ever taken, you tried to take the AP free response test and see if you could pull that off. I'm not sure I could. But the cool thing is, because the overlearning, they were able to pull that off. And I'm not sure JavaScript makes that transition as well either.
So just on top of that, say for like me who is teaching middle school, and I know yesterday you said you've taught 5th graders.
Yep.
Things with this. Would you skip the block-based completely and just go straight Python?
Personally, probably. Yeah, Scratch and Alice and all those things are really nice. I learned Alice and I used to teach it at high school in my Mecca class. That's why I used to teach it there. And I like them for many reasons, for many other reasons. And so once again, it depends on your population.
Okay.
If
I mean, I've used Scratch a lot.
Yeah. And if you don't have any prerequisites relative to mathematics, once again, that may be another rationale for using something simpler as an intro. Okay. I always had Algebra 1 as a prerequisite, so I kind of cheated. If you think about it, they had to have a B out of Algebra 1 class before they could even sign up for my class. Yeah, that was a different population there, doesn't it? So therefore, now could I pull it off otherwise? Yeah, but it'd be a whole different course.
Okay.
Can I give a second perspective?
Sure.
So my thoughts, I second what Kirkwood said about you are the key important thing. If teaching block coding is something that you understand, something that you're really good at, and if you can drive that passion into students, at the high school level, we want students who have problem solving. If they come into us with problem solving, no matter how they've done it, block-based or anything else, we love that because we can run with that.
Mm-hmm. Yeah, I'm a STEM teacher teaching myself coding because coding seems to be what a lot of the kids want. We do a lot of problem solving in STEM, but that's hands-on, you know, hey, why didn't your catapult hit the mark? And so I'm in this to try and learn some pedagogy and some other things and actually learn how to program in this darn stuff. But coming from middle school.
I've definitely struggled in the past because I do a middle school exploratory class as well as a high school set of classes. And my middle school program, I often am given kids who have literacy issues, pretty significant ones. And I definitely tend towards block programming for kids that are less literate because they get so tripped up on the syntax and formatting. But if you have a group that are literate, I think that learning text-based programming is far more valuable. It starts to get that abstracted aspect of how do we take these concepts we learned, and many of them already have experience with Scratch. Parents are getting kids in Scratch, you know, 2nd, 3rd, 4th grade. And so by the time they get to middle school, I think we'll see this more and more. Kids are really ready for the next step, whatever that is.
Okay, because yeah, I mean, in my advanced engineering class, we use Robot C, which is an antiquated linear type program because we use VEX. But I'd love to give my advanced kids, you know, it looks like Python might be best for that. And then go play choose your own adventure game programming with Scratch for my 6th graders. Because we do have a lot of we have ELs, we have a lot of low socioeconomic, you know, yeah. So I appreciate all of this coming from computer science teachers because we don't have any at the middle school level.
I want to offer my perspective because I teach 1 semester of Snap, which is the cousin of Scratch, and then 1 semester of Python. And many kids come in there blustering, thinking they know everything, and they can't write the code in Snap. And I'm thinking, if you can't write the code in Snap, don't talk to me about text-based coding.
Same thing as college, but wait, same thing.
Exactly. So I'm like, is it so easy? Then do it. Do it in 2 minutes. Show me. And so I get really annoyed when people are like, oh, Snap, that looks so childish. And I'm like, so what? Show me that you can do it, and then you can move on to Python. But anyway, I'm sorry if I sound angry.
No. I appreciate the input. Again, I'm coming from a non-coding, non-computer science background. Again, Fortran was my only language back in 90. Yeah. So I really appreciate all the input and things. That's why I'm taking this class.
I really do think it's,
Another thing to look into is Game Maker. That's one that offers both text-based and drag and drop options. It does take a little while to get used to, but once you're used to it, teaching it to the students and the videos that are already online do help with that process quite a bit.
Okay, thank you. Yeah, no, I do also like the fact that you guys are presenting this as a solving problems first, and then the language is kind of secondary to learning how to solve the problems.
absolutely. I mean, I love C++ and like Arduino and stuff like that because it gives a little bit more of a tactile feeling to those things, even though C can be kind of a beastly, cruel language, you know. But I think it all depends on what supports you build into each of your little things, right? So even the most complicated code can be simplified if you give them sort of some base structures to work with from the beginning.
Okay, well, thank you for letting me jut in and interrupt.
No, this is perfect. This is what we can do in a normal thing, and it's hard to set up this way, so I appreciate it. One of the things that works really well along all of this, think about it, why do high school and middle school math teachers have to take a real analysis and topology? And I mean, that's insane. There's nothing that has to do. I mean, if you have a math degree, what does that have to do with what we're teaching in high school? That's wacko. Well, the rationale I think behind it is twofold, but one of them is that you know where they're going. So if we teach right, these people, we're helping them get there. So if you're doing Scratch or Game Maker, you're doing anything, you knowing a bit about Python and stuff up here, you know where you want to head them. So as you're teaching them Scratch, you can allude to, now these fit together, these puzzle pieces fit together, the same with Alice. This works this way, but now notice, look at the codes here. See what this loop, see what's going on. So you can start prepping them for the transition, even if you never teach the advanced course. Mm-hmm. So, but we don't tend to think that way because we don't know the thing above it. I mean,
and that's where
this is perfect, and that's what I'm saying. Even if you guys never teach Python or anything else, that's why I really wish more people would. The Java class that I taught started fading. I love teaching Java stuff because people say, "Oh, I don't get that high. We're not going to get." But if you understand it, my gosh, then you could teach all the other stuff below so much better. But that's okay.
And selfishly, it's actually to teach myself Python. But thank you.
Yeah, there we go. Go for it. All right, perfect. These are great questions. And we have, anything else before we get back to the little code a little bit or not? Okay, and there's like 76 things in the chat. And you guys got to realize, once again, I haven't looked at Squat because I can't. So I will look at them later. If there's something important, you can email me personally. If you really have something more, just put it in the chat and I'll get around to it, especially since it was Tuesday, Wednesday. Now I have a gap. So I'll have time to look at the stuff that Kathy puts up on the stuff there, okay?
Don't worry about it, Don. It's mostly just side conversations kind of adding to what we've been talking about. There haven't been a lot of questions.
I just was figuring it was stuff like, oh God, can you believe he's still doing this? What's going on here? You know, but that's all right. The snarky comments, I'm waiting. I guess I've had Judson and Reams too long. So I just was assuming that's what was going on. So, all right. Now back to and am I sure? Yeah, I am sharing that screen. Are there any other further questions relative to this A-level, probably third or fourth assignment in if-then-else sequencing? There's no way we would start here. So this is like the highest level problem before I finished if-then-else sequencing. So is there any other questions relative to that? Okay. Cool. Then we will move on to the one that I think I have a problem with both. The AP went along with it. Languages, unfortunately, let me backtrack. Constructs, no one will do this unless you're really twisted, but way back when a guy named Donald Knuth wrote 3-volume set, way back before computers were even going on, and there's no point even writing it down because unless you are pre-electricity, no one knows who he is even. So, but the fact came out to be, he said, what are the minimum number of stuff we need to solve problems? What are the minimum number of command ideas that we need to do to solve any and all problems? And it's a whole treatise about that. Well, Python and some other languages decided that you only really need 2 loops to solve looping problems. The for loop, so let me backtrack. So therefore, for our students, and the AP test proves this over and over and over again, students will grab onto one looping structure because they like that one, and they will use it to solve everything. And when you correct AP exams, you will just, I don't know if anybody in the group has done that before, but it is insane how convoluted and hardworking and stupid mistakes students make because they don't know what tool to pick up. Python only offers us 2 looping constructs. It offers 3, if you see the decision construct, and we'll come back to that in a second about when do we use just if and if, or when do we use an if and an else, elif, or when do we use multiple series of those and embed them. We have to think about that. And we have to set up problems for the students to see that it matters. And that is my job as a teacher. My job is to make the AP test easy for them, if that's where we're heading towards. And if you're doing middle school, please, any young Latina or any young woman or anybody, but anybody that will increase the diversity of our entire base, please just expect them, set them up. I was sharing that with Kathy the other day. What I loved, we at North High, well, the programming competition that is now done at Linfield used to be, Minville used to be done at Willamette, and we did pretty good at the beginning. We did really well. And so they came and did an interview. We had the first team that had a young woman on it. As a matter of fact, she did 3/4 of the problems. Without her, there would have been no, we got her PhD in mathematics and physics. It's a brilliant young woman. But they were interviewing, they came in and interviewed a group of the kids about it. And I liked it because she said, the interview, and so I'm teaching class and kind of listening up front, trying to figure out what she's going to tell this guy. She was a real positive loose cannon. I loved her. So she was saying, he's asking, why do you think there, he looked around the room and says, why are there's a lot of girls in this class. This is really cool. And he said, why do you think that is? Well, she said, Kirkwood treats us all the same. And I went, but I should have waited for the pin, because she said, like trash. She treats us all the same. He treats us like trash. And I went, what? Internally, I'm going, oh, and acid coming all over the place. I need to, what are you doing? Amanda, what is going on? And he said, he said, what? She's laughing. And she says, he never lets us get away with anything. If there's something that makes us better, he'll push us and challenge us and question us all over the place. He doesn't let us get away with just doing easy answer and doing this stuff. And that is so fun, because other times people will just kind of pat you on the head condescendingly and go by. And Kirkwood will treat us like trash and force us to be recycled in the right way. And I just thought, that's not quite the way I would have said it, but thank you. And I think that's what we do. You guys teaching elementary or middle school, please look at these people of diversity that we need in ours and radically encourage them to move up the line. And encouraging them doesn't mean patting them on the head. It means pushing them down the line. There's no limit. If we have a chance later on, I'll let Mike talk about one of our favorite students from North High, Latino young gentleman who just barely spoke English as a freshman and ended up winning the Bill Gates Scholar as a senior and did insane stuff. And that's what you can produce. And that's cool. So the looping structure, just a slate. I get into the kids, sorry about that. But in here, looping structures are part of the problem is that Python only allows 2, when in reality, I think there should be 3 looping structures. There's a ball peen hammer, there's a claw hammer, and there's a jewelry hammer. And Python doesn't provide the jewelry hammer. So we just have to figure out how to use these 2. But the fact is that students will not use them, and they will avoid the while loop, even though it's radically easier. So let's backtrack. These tools we're providing them with, when do we even need to pick up a loop? Part of the problem. I read the problem. And this is what I would do to the kids constantly. When I introduce this, let's do that real quick. I'll kick off this one in a second. Wrong place here. I want to just do this. I want to give you some problems. If I want to know the average score of 100 students, what am I going to do? Pseudocode. Somebody talk. I mean, go for it. Unmute yourself and have the guts. Like I said, teaching adults is worse than teaching. It's the worst thing because no one wants to put their line.
We add them all up and divide by the number of students.
You got to get the
so I'm going to, so therefore I'm going to get a score, 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 get a score. I'm going to do 100 get a scores and then add them all up, right?
You're going to loop to get a score.
Okay. Do you see my point? Do you see what and by the way, yes, this pain in the butt approach, I love. You guys are radically more gentle and kind and generous than, and you can ask Judson and Reams, both of them. That was not my style. Once I got to know them, especially, it was worse because that is kind of fun interaction there. And I said, by the way, when you get out into a team at Google, you're going to have 3 people who know the answer to every single question. And if you let them get away with it, you ain't going to be on the team. Plus, you're not going to get the results that you want. So you need to learn to stand up to them and do it now. So I want to give you practice. Here we go. So therefore, yeah, we have a loop. What type of a loop? And why?
For loop, because you know how many you got.
There we go. I said it's 100 students. Therefore, I know a for loop does that task. It'll go, right? And I can just say range of 100 because I don't care about the number. I don't care if it starts at 0 or not because it has nothing to do with the mathematics. So I just go range of 100 and we got it. So I ask the question once and do my summation line internally. And then where do I calculate the average?
Outside the loop.
Why?
Because you don't want to do it 100 times.
Thank you. But stop and think about your students, right? Stop and think about your students. By the way, there's an AP multiple choice test question right there. They'll put the code and they'll put the calculation of the mathematics inside the loop, and they'll ask something about efficiency and time and all that stuff. So having that happen when you're an intro course builds up the whole pile of stuff. I'm prepping for AP tests the second week of teaching in my intro class.
Wouldn't you
just
ask
by my questions
about a more robust way so that it would be applicable to other classes or other sizes of classes that you would have the variable put in for class size?
So you could, yeah, great. So you could handle that 2 ways. If you knew how many students you had, what could you do to make this robust and more flexible?
Would you set the range to a variable so that you could change it depending on if the kid leaves?
So you would ask the teacher how many students they had, and you would ask that where?
At the beginning.
At the beginning of the program, before the
beginning of the loop?
No.
Well, what do you mean? No. See, I love teaching geometry. I love teaching proof geometry, guys, because my students, I would say, I'm going to take your words. I will do exactly what you tell me. I will not cheat. I will not lie. But I'm going to do exactly what you say, but I'm going to make it screwed up at all possible and make that happen. And they would say, do this. And I went, okay, and I do it. And they go, no, Kirkwood. I said, but that's what you told me. And isn't that what we're going to do with the computer, right? So yes, we get how many scores before the loop. Then we use exactly right that variable as our control variable and the range. And then we get the score and tally it outside. Correct? Perfect.
What
Everybody
if
with
I
me?
want to be difficult and I don't want to tell you how many students I have?
Ah, perfect. Thank you. I love, see, this is what I do face to face. This is so much better. So that's my next exact question. I love it when you take my next thing that I was going to say. It's better yet. Because I don't ever count myself. I hate numbers. Numbers are boring to me. I'll be honest with you. That's why I love teaching geometry and then jump to calculus. But the fact comes to be is numbers bore me. I don't ever know how many students I had in any class you ever gave me. I wouldn't know. So if I don't know, I give the exact same problem. Input an unknown number of scores and output the average.
So would you have like a thing? Okay, this again. Remember, I'm going to ask stupid questions.
Oh, this is what we want here. Yeah.
There are no stupid questions in my class. So would you
Well,
have
but you're not. You're my class. You're my class. So
well, I know, but when I teach, there's no stupid questions. So would you have an indicator though when you are done entering? Would you have a prompt or an indicator?
There we go. If we did this by hand, you would have to say, okay, hold it. You're going to give me a bunch of scores, but I have to know when you're finished. So therefore, can that be a for loop? And the answer is no, it can't be. Matter of fact, the way I introduce this loop is exactly what we just got finished doing. I will give a quiz that will cover if, thens, and for loops. I will do that, and we'll go over the quiz that day when they come back. And the very next question I will ask, there'll be a question on the test that someone screwed up the for loop with the average. I will take it exact question and do exactly what you said. I say, now, what do you do? So I'm going to say, what do you need from me? What do you want me to teach you? You got to give me some way because I don't know the number. So I got to have a loop and I'll say, what do you need? What do you need that loop to do? One of the coolest things I did when I got doing geometry big time was actually not the triangle chapter with side angle, side and all that garbage. I would not use the book at all. I would say, we're going to do proofs about geometry. You tell me what you want. And they would literally develop every proof, every theorem through the entire chapter, and they would name them what they wanted to call them. And we would solve all the ASA and all that garbage. They would do it. It was so much more fun. And they memorized, there was no memorization because it was them. And they would, every year, I was blown away with how they would pull it all off. Well, that's the same thing we can do here. You need a loop. Okay, can't be a for loop. So what does the loop got to have? It's got to have some condition. You tell me when we're finished, correct? Now, by the way,
it's a while then.
There we go.
While.
Yeah, exactly. You see, so what's going on is, this is what online canned programs can't do. This is what you can do. And by the way, that technique, we're going to use it. It depends how far we get this week, or this month. We're going to use that technique in really elaborate questions, this transition. So we need another loop, and it is while. That's the while loop. And therefore, the basic construct for the while loop, I wish we had a do loop or repeat until loop in Python. We don't, because we actually have to do two kinds of problems with the while loop. There's another question I would give them is, I want to roll a dice. I want to keep rolling the dice until you roll a 7. Well, is that going to be a for loop?
Well, no.
Nope.
Because
When you're going to get a 7.
I don't know what the range would be, correct? No idea at all. But notice, intellectually, that is actually a different problem thinking than the average grade thing. Why? What's different about those two things? Rolling the dice until I get a 7 and inputting an unknown number of grades and I want you to calculate the average. Those are two different hammers. Or if I had two different hammers, it would be better.
Because you haven't gotten anything that first roll, so you got to at least roll once? I'm not sure.
There we go. Actually, that is part of it. That is, in those of you, I could tell some of you read computer science textbooks. So, because that's one of the rationales behind it, right? I can tell you cheating, but that's okay. I love pre-knowledge. That's great. But yes, you have to roll at least once to do that. By the way, with the gradebook problem, would I have to have any students in the gradebook to output the average? Nobody's, no one may show up, right? If I'm running, we'll get this later, if I'm running a store, right, or a bar nowadays, that's good. If I'm running a bar, there maybe not no clients coming in today. So there may be nothing coming in. But if I want to roll a dice, I got to roll a dice once. So notice that's one tweak that's different. The second tweak is that I know what to exit on the dice. When I get a 7, I'm out of here. On the grade, unknown number of grades, tell me what makes me quit.
Should be a
How do I
user.
know I'm finished?
Shouldn't be a user input that makes you quit.
Yeah, I don't know, do I? I never like to user input, but good program, I have to tell the user what to input to quit. Because there's not I call it a natural flag. 7 was the natural flag. 7 will occur, and 7 will happen sometime. I don't know, maybe 1,000 rolls on the line, probably not. But it could
I don't know
be.
what dice you're using, not a D6.
Well, 2 dice. Oh, sorry. Whenever I say dice, I tell my smart mouth, look at this. You're all right. This is good. We're getting real now. Everybody's flipping me crap. I like that. That's good. Now we're getting out of the, she was here yesterday.
Must be
So Kat's already had a day to build this repartee up here. So that's great. So, yes, in my classroom, if I had done the sequentially, I would have said, anytime I say dice, I'm talking about 2 6-sided regular dice, unless I specify.
He is saying dice and not die, which is
because students never remember die and dice. That's I'm an English teacher, so I know the difference, but that's okay.
Wait, what don't you teach? We've got geometry, we've got math, we've got computer science, we've got English. What don't you teach?
Well, most people say what I do isn't very good teaching, so maybe that's, I don't know, perhaps. If you teach at small schools, I also taught personal finance and PE, so that's okay. That's at Jervis, so here we are. So
my first class with Kirkwood was Mecca, where he taught math, English, and computer applications, and programming. A little bit of programming when he could.
Yeah, the poor suckers. This is why Judson's the way it is. The sophomores were stuck with me for half a day, so that tells you why he is a little twisted already. So that was it. Yeah, until No Child Left Behind said I wasn't competent, but that's another whole thing. That was probably true before that, but that's all right. So back to this. In reality, 1 had a natural flag. When we got to 7, we're going to quit. This loop, there's no natural number that tells me I'm finished the scores. I have to tell the user what numbers to use. And what number would I give them? What types of numbers would be appropriate for them to say, aha, this loop is finished?
Why does it have to be a number? Can it be a letter or a space bar?
It could be, but then Great point. But then you have to deal with, especially in other languages, you have to deal with the syntax of handling text as well as numeric values. So you may or may not, just like the 0 for the quadratic formula, the roots, those types of side issues, you may or may not want to deal with at the beginning. I personally do not. Because the fact is, I want these kids to be jazzed about stuff. And if I start throwing more syntax and stuff on them, I don't want to do that now. Later on, when they get to real applications, I throw all that garbage at them.
So assuming you don't give anybody negative scores, should you use negative numbers?
There we go. Why?
Because chances are no one is going to earn a negative score.
Hopefully, unless they misspell their name or something. Yeah, okay, exactly. Or you can make it a big score, right? So you pick we called it an artificial flag, a value that does not occur naturally in the sequence of values that you're inputting. So exactly right. Those of you who coded in the real old days, we would always use 999.
Why couldn't you just ask them at the beginning, how many, like it's unknown. So you run your program, they're going to know, oh, I've got 30 students today and 29 tomorrow. Ask them that a beginning one, because then you could have your loop run that many scores and kick out automatically.
But
what if 3 people were absent?
Yeah.
That's when you run your program. Later you might have to go and fix that, right?
Yeah, but then I have to sit and count the stupid tests.
Okay.
And I always say my job as a programmer, unless I work for Microsoft, is to make efficient programs. So therefore, I want to make sure that I do everything that. So you're right. And matter of fact, guess what? They do ask those sorts of things. But I want to make sure that I say there are times when that is not known. And matter of fact, it may be that you're reading a file later on. You're reading a data file and you have no idea how many elements your customers are in that data file.
Okay, so could you have at the beginning, say, hey, type end when everything checked in, and then you're just going back and checking for that.
Exactly right. So the for loop is it's the hammer, the claw hammer, when I know how many bodies or how many things I possess. If I don't know how many things I possess, that is in Python going to be the while loop. In other languages, we have another loop that deals with the natural flag and artificial flag. But here they bundle it into one, the while loop. And so yes, now, how do I control that while loop really matters. And students mess up on that. And so I let them, if we have time, maybe we don't have time today, probably, since we only have 10 minutes left of this thing. But if I had time, I let them try everything. So I would say, let's do this program. You tell me what the code is. I give them the syntax of the while loop, and you do the code, right? And so therefore, and I don't want to even show the code too much. So don't worry about the specific syntax of while. Let's do pseudocode. So what would you think we would do? Pseudocode wise. With an unknown number of students, output the average. And those of you who programmed this before or definitely put up with me before, you be quiet. And that way I won't embarrass you because if you screw it up, I can't say, but I taught you that 4 times before.
So wouldn't you nest a for loop in a while loop?
Why?
Well, I don't know. I mean, while the input is not end, then you go down and you can calculate your average.
But then I need to get, if I have a for loop, that means I know how many scores I got. I don't. Right? Now, if we have more time and I could do this, would it be good for me to do this on the whiteboard, or is it okay just to talk? This okay?
I think this is okay. It's nice to see your face. So what about if
I know
if
you're
else?
lying now, Kat. That's really pushing it hard. So that's okay. Well, that's all right. There we go.
So what about an if else for the end statement?
Okay. We could do so. So
if the input is a number, then that's a score, and you register that, and you can do that in a while loop.
Ah, okay.
Else, if
you might want to take notes. Yeah, take notes. So we got a big while loop thing, and the syntax is while something. And inside that while loop, you've got if. So you get a score. So here we have a while loop. We get a score, and then we go if that score is greater than 0. If we use -1 as our flag. If it's greater than 0, and we won't worry about the max. We won't. You could trap double with the conjunctive statement, but I'm not worried about that right now. So if it's greater than 0, then we do what inside that if?
We register that as a score, and that's 1 towards our range of what scores are.
So what do we do when we want to do average?
Well, we have to add them all together.
Good.
So
That's right. So we do a summation line. Cool. We'll leave it at that. And we do a summation line, and then else.
Else -1. End.
Okay, well, the loop, so we got to talk about what is the loop going to do? What is the loop going to do itself? The while loop, guess what? The while exit, so here we go. The while syntax is while score is greater than -1, colon. So we have that. So inside that while score greater than -1, we did if this, so the else, well, maybe I don't need an else because the while will take care of that, right? It loops back up to that.
Okay.
Okay, so, well, that handles that situation. Okay, that means every time I run this loop, I come in the loop. Now, by the way, what does that mean I have to do from the very beginning before I do this loop? If you're taking notes, you might want to sketch this pseudocode out. I would be doing this on the whiteboard if you wanted to.
So before that, you have to declare what any variables and input.
So we call it score, right? So score, we declare it as 0 to start with, right? So score 0, while score is greater than -1, go in this loop, get a score. If score is greater than -1, add it up. And then it'll come back and say, oh, it's a 20, so it's not less than that, so it goes in again. Does that, and by the way, some of you should be going, this is perfect. This is exactly what I want. Because in real life, we have someone shooting down an answer before we have a chance to analyze it. And I want to start from the very beginning, freshman year, doing this stuff. So first, does that work? Would that work?
How does that, though, give individual scores? Because you're changing the name of the variable every time you put a score in.
No, you're getting a new value for score, but what have you done with it? What do you need to calculate an average? All you need is the total.
Sum.
and the sum. So whenever we get a score, we added it into the sum. So sum was 0. I got a score, we added up, so sum is now 20. We got a next score, score is 30, so sum is now 50. We got the next score, it is 80. They typed in -1, we quit.
And then at the end, we divide by the number, the total number.
Divide by what?
We divide it by the number of scores.
But I don't know how many scores we got.
Well, we had to keep track of that.
Oh.
Okay, so we
Right?
need a variable.
You see
that
what I'm
can
trying to get
check.
across here? This is how they can think it through rather than looking at a textbook or a canned code that says, here are 6 examples of while loop. This is how you do it. What we just did will stick so much better. And what's really cool, it will stick the best on the student who gave that answer, who had the guts to do it, and they'll never make that mistake again. The airheads who thought they knew how to program all of this already, they're going to make that stupid mistake, and I can tell you they will, because I corrected their AP tests. So there we go. So yes, in this one, I had to have 2 summations, didn't I? I had to have the summation for the score, and I had to have a summation for a count. Cool. Now if I had both of those, now with this algorithm, now notice we didn't write any syntax. We haven't wasted our time typing things in. We're discussing it. Where yesterday I talked to you about, I would give this assignment, then I'd say, anybody want to sit and talk with it? You can stay up front here and we can talk, and we would talk quietly. Yes, I can talk quietly. I know it may be hard to believe, but I can actually do it. And I would whisper to this group. And what we just did is exactly the conversation we would have with that group. And the other airheads would be making all those other mistakes and then screwing it up and have to recode it. And I love that. I want them to want to be here in this discussion. Rajani, as you were saying that, that's what I'd want. I want them to desire to communicate what's going on, especially on a big project or a hard, challenging part of a big project. Right? So would this work now? So let me go. We set score to 0, total to 0, and score to 0. While score doesn't equal, it's greater than -1. If score is greater than -1, we total up and we add 1 to count. And we go back and do it again and again. When it got to -1, it didn't go in and add it. It got the loop, it kicked out, and then I could do average equals divided by num, or count. Perfect, it worked. Working solution. Is there any way, so I always ask the question, is there anything that seems redundant or inefficient that we can make this problem faster? Because if I'm working for Google, I come up with an answer, that's the first thing we did as a team. To say, okay, this works, but we need to sell this, and if we can jazz this more, it's going to be worth more. We'll get more customers, unless my name's Microsoft. It doesn't matter. So here we go. Sorry, I have a whole bunch of students working for myself, but I love picking on them. It's just pick on the giants, why not? So does that work? Is there anything more efficient in this process or seemingly redundant? And those who've done it with me, quit shaking your head, Judson. Well, at least that means you remembered it. That's good.
This might not be related, but we do need to print the results.
Oh, yeah,
too.
we do that down below. Yeah, we'll worry about all that. And for time, I'm going to have to slide in unless someone's ready to go for it. Oh, go ahead, Judson. Or somebody else. Philip, are you going to do it? Or okay.
So, I mean, asking the user over and over and over again seems redundant to me. So,
But we have to.
Well, I was going to say having an array that was already pre-populated or a data file that we're reading from.
But then, and you're right, but then I have to teach file manipulation, and in any language, file manipulation, and a bunch of tutorials do exactly that, and you ought to see the classroom just die. Anybody who is on the edge, think about someone who's never done programming before. Now you're telling them about data files. Now the guys who have kept the gaming and all that crap, they know all that. But the people who have never done this before, you just lost half your class, and most of those were young women and kids of diversity.
Judson, you just lost me.
There we go. Okay. So therefore, I don't want to deal. You're right. Files is a topic I love, but to me, it is the most. It's after lists and after everything else. By the way, it's not even an AP topic because file manipulation is radically different in every language in every place. So therefore, that's another reason. So without that, and I need time-wise, I'm going to do it. Redundancy is I have to check the score twice.
Okay.
Notice the while loop check the score, and then you check the score inside the while loop with your if. right? The computer had to check it twice. You said while score is greater than -1, do this. And inside the very first, after you got a score, you say if score is greater than -1. So you checked it, every single score, you got to check twice. And if I could avoid that, that sure would be nice, because that takes computer time. And if you're doing LASIK eye surgery on my eyeball, I want this sucker to be fast. I don't want my blink to get in the way. So what do? Well, and I'm going to give it here. Therefore, there is a rubric, a canonical solution for while loops, for artificial flags, which is this one where I have to make it up. You get the flag variable first, then you do the while, and now inside the loop, you do all your junk. You don't need to check it. So watch, if I get score, if they type -1, the while loop says while score is greater than 0 or greater than -1, it would not do it. It would skip right past it. And then I could do my if then else saying, if num is 0, you didn't have any students take this test. Else, here we go. And then inside the loop, I don't have to check it again. But careful, if I do that, by the way, that's what students, I love this conversation. What we're doing is exactly what I have with my students here. This is real. So therefore, inside the loop, I would tote equals tote plus score, and then I do count equals count plus 1, and that's it, right? Cheshire Cat. I wish I could pull that move off, but that's okay. I should have one of the screen background instead of the sheep in Scotland. I should have a Cheshire Cat smile pop up behind me or something. Here we go. I'll have to work on that. No,
So
that wouldn't work. Because what's going to happen in the loop?
Yeah, you have to ask for the
Yeah, you're constantly looping in. Yeah, Troy, we got to get a new one. You never get the next score. It's going to be an endless loop. By the way, that's a direct AP multiple choice question right there. What is this output? And it is made mistake by over 50% of the students. Because now you never get another score, so guess what score is? Score is 20, and it comes back and says, well, score is greater than 0. Well, it is, so it goes in, still greater. So what are you going to do? So it is get score, get variable. While variable doesn't equal the flag or is greater than the flag, depending on your approach. Do stuff, whatever math or other stuff you have to do, and get variable again inside the loop. And students will say, isn't that redundant? And I'll say, tell me how many scores you get for every loop. Do you ever get 2 scores for a loop? And the answer is no. You had to write the line of code twice, but execution, it is never redundant. That is, therefore, that algorithm, there's your algorithm, folks. For unknown number with an artificial flag, that works always. Get variable. While variable doesn't equal or is greater than flag, do stuff, get variable again. That will work always.
This has an official programming term. It's called the fence post algorithm.
Yeah. And yeah, I just call it artificial flag. Yep. I use the metaphor of the guy on the construction site with the flags. And now we are 2 minutes past time, so I will do this. Now, I just need quick feedback, hands and stuff. Is this effective for you? My goal is, I was thinking about doing more constructs as you look at the thing, and then more of the algorithms, and then moving gradually into lists, which is a big jump, and the most screwed up piece of teaching in every textbook. I've never found one good. So I really would like to spend some time there. So if this is okay, we'll kind of continue this way. I love your input. Guys, this worked very effective, this last part where, the question was asked and we went with it. As long as we have people courageous enough to go for it and hang themselves out to dry here.
Oh, no problem. Anytime.
Yeah, I'll show my lack of knowledge any day.
There we go. Please let me know otherwise what's going on. And like I said, we thought about an advanced class. You can talk to Kathy independently and OCS to people. If we end up wanting to do an advanced algorithms class, that would be an advanced algorithms class, which would be really kind of fun. But we just they make those choices. And this was the volume thing here. So I hope those of you who are beyond this line of code, at least some of the pedagogy, the approaches are effective for you and are meaningful. I hope that works. Okay. Fantastic. This was fun, at least on my part. I enjoy getting to know some of you well enough to harass you, and I love some of you doing this stuff in a positive way. This is great. And I also notice people who don't want to be seen and don't make any other comments. That's good too. That's cool. If this was a normal classroom, you wouldn't get away with it. I would be calling on you. So you lucked out with this type of stuff. There we go. So here we are. All right. So thank you very much for putting up with this. And I guess I'll see some of you